Just a second. Relations. Now, previous day, we have already discussed the concept that if we are having a set P and the element of P are A, B, C, and if we are having a set Q and the element of Q are Ali, Bhanu, Binoy, Chandra, and Divya. So if these are the element of set Q, then we can write the Cartesian product, that is P cross Q, as the ordered pair, that is A with Ali. Then we can write A with Bhanu. This one we have already discussed in the previous class, right? A with Binoy. Similarly, dot dot dot, like all the ordered pair, all possible ordered pair we used to list down, and then B with Ali, then B with Bhanu, then similarly C with Ali and C with Bhanu. This way we used to make the list of like all ordered pair, and that is our Cartesian product between the set P and set Q. Today we will be discussing about the relation. So whenever we are going to talk about relation, it will be a subset of this ordered pair. Now, what's the meaning of subset? We have already discussed the concept of subset in the chapter set. So it will contain few elements or maybe all the elements from this Cartesian product. So suppose our relation is R is a relation where R is a set of all ordered pair XY such that X is the first letter of the name Y. Where X belongs to P and Y belongs to Q. So we have to make the list of, we have to make a set of all ordered pair. But here the condition is given. In Cartesian product, what we used to do, there is no condition. We used to take the first element with the other element. We used to take the first element of this one with each and every element of the second set. Similarly, we used to pick the second element of the first set, and then we used to take it with each and every element of the second set. That was Cartesian product. Without thinking, just take each and every possibility and then we are done. But here one condition is given. That condition is called relation. The relation is given between the ordered pair X, the first element, and Y. So what is the relation between X and Y? Let's see carefully. It says that you have to only write those ordered pair which is where X is the first letter. Can you see the red underlined part? X is the first letter of the name Y. So X has to be the first letter of the name Y, where X belongs to P and Y belongs to Q. So you have to take a X from P. Suppose P is having three elements, A, B, C. So if you are taking A from P, then the other ordered pair, the other element of the ordered pair will be a name which must start with A only. So we are having A, and there is a name which start with A. That is Ali. So this will be the element of this relation. Now next one will be A. Now there is no name which starts with A. So we cannot take A with any other name. Okay, because it says clearly over here that X is the first letter of the name. So A with A name, B with the name which starts with B, and C with the name which starts with C. This much only we can take it. So B, the name which starts with B, if you will go up, are Bhanu and Binoy. So one by one we will take it with B. Okay. So we can write B with Bhanu, and we can write B with Binoy also. Now the element of the first set P, that is C, and we will search, is there any name which starts with C? If there is no name which starts with C, we will not take C. So I can see here Chandra is there which starts with C. So we will write C with Chandra. And now we cannot take D because there is no element D in our set A, in our set P. P doesn't contain the element D. So the name, the other name, that is Divya, that we cannot take over here. So this much, this is our relation. Like according to the relation, we have listed down all the element as per the given condition. So the condition was X is the first letter of the name. We have taken all the letters like X, we have taken all X, and Y such that Y is the like A with Ali, B with Banu, B with Binoy, C with Chandra. This was the given condition, and accordingly we made the set. While doing Cartesian product, what we have done, we have listed down everything. As you can see, A with Ali, A with Banu, A with Binoy, A with Chandra, A with Divya, everything we will list down. But while writing the relation, we have to keep in mind what exactly the condition is given. According to those conditions, we will pick the ordered pair. Is it clear, Lina and Nizan?
Yes, ma'am.
Yes, ma'am.
Yeah. So let's do a few examples related to this concept, relation. Okay, today we will be totally focusing on this relation. Next day we will be talking about the domain and range of the relation. So example, let A is equals to 1, 2, 3, 14. Define a relation R from A to A by R is equals to XY, set of all ordered pair XY, such that the condition is given as 3x minus y is equals to 0, where x, y both belongs to A. All right. So this is the given relation. Now we have to make the list of all ordered pair which will satisfy this condition. Here the condition is, as you can see, it is 3x minus y is equals to 0. So we have to keep in mind that this condition must be satisfied while making the list of ordered pair. How we will make the order pair? To simplify this one, can we write it as 3x is equals to y? Or can we write it as y is equals to 3x? Can we?
Yes.
Yes. Izan, is it same thing?
Yes.
Exactly. Those are same thing. We have just changed the side of y. So we can write the given condition or the given relation as y is equals to 3x. Now we will make the list of ordered pair. So our relation R will contain the element. Let's list down. The element will be whatever you are taking x, that is okay, as x and y both belongs to A cross A. That means it must be a subset of A cross A. So while writing A cross A, how we write A cross A? Like one of the element of A with another element of A. Then the other element of A with, again, we take each and every possibility of A with A. Here also relation will be a subset of that Cartesian product only. So from A we can pick anything as X, but Y must be 3X. Okay. So if we are taking X as a 1, I am picking the element from set A, and set A is having 1, 2, 3, 4, 5, 6, 7, 8 till 14. So I am taking the first element from the set A, that is 1. Okay. Now with this 1, our Y will be 3 times of X. That condition must be satisfied. So Y will be 3 into 1, that is 3. Now if I am taking the first element as a 2 from the set A, then Y will be 3 into 2, that is 6. Are you getting it?
Yes, ma'am.
Yes, Izan, can you tell me what will be the next element, next ordered pair?
3 and 9.
3 and 9. Next,
4 and 12.
4 and 12. Next,
5 and 15.
can we take 15?
No.
We cannot, because set A doesn't contain 15. Okay, so we cannot take like the element of A is 1, 2, 3, 4 till 14, and the Cartesian product or this relation must comes from A cross A. A cross A will not contain 15, right? So this is the required relation. Is it clear?
Yes, ma'am.
Yes, ma'am.
The other one. The next one is define a relation R on the set N of natural number by R is equals to set of all xy such that y is equals to x plus 5. Here x is natural number, less than 4, and xy both belongs to natural number only. So this is the given relation. Let's write it. So R will contain okay, just a second. Can you see the screen?
Yes, ma'am.
Yes,
Okay.
ma'am.
So here our relation R contain the ordered pair all xy such that y is equals to x plus 5, and x is natural number less than 4. Both xy belongs to natural number only. Let's make the list of all ordered pair. So here we are having xy, where x and y both are natural number. One more condition is given, that x is a natural number less than 4. So what can be the first element? What can be taken as a x at first? Lina?
1.
Exactly. So if x is 1, then y will be?
6.
Exactly. Then x can be
2.
with?
7.
Then x can be?
3 and 8.
Then x can be?
It has to be less than 4.
Exactly. It has to be less than 4, so we cannot proceed. Okay, so 1, 2, 3, these are the only natural number which are less than 4. So we are done. Let's do the next one. If A is equals to 1, 2, 3, and 5, and B is equals to 4, 6, 9, and a relation R is defined as ordered pair XY such that the difference between X and Y is odd, where X belongs to A and Y belongs to B. Can you tell me what will be the element? Yes, Izan? We have to list down all such ordered pair where the difference between X, like X minus Y, has to be an odd number.
1 and 2.
1 and
4.
1 and 4. And yes, when we will find the difference, it will be an odd number. Next.
2 and
2 and
9. 9.
Yeah, 2 and 9. Can we take 1 with 6 also?
Yeah.
Yes, we can, right? So 1 with 6 also we can take. That will also be an odd number.
And
Then
3 and 6. 3 and 4.
Then
5 and 4.
Then
5 and 6. Yeah, that's all.
that's all. Let's check. Are we on the right track? Like, yes, mostly we have listed it down. Let's cross check. So 1 with 4. Yes, that will give odd number when we will find the difference. Then 1 with 6. Yes, that will also give an odd number. Then 1 with 9. No, that will be even number. Then 2 with 4. No. 2 with 6. Not at all. 2 with 9.
9.
Yes. Then 3 with 4. Yes, we have listed down. 3 with 6. Yes. And 3 with 9. No. Now 5 with 4. Yes, we have written it down. 5 with 6. Yes, we have written it down. And 5 with 9, it will not be there. So yes, we have listed down all the elements. Yes. So these are the element of element as per the given relation. Okay, these are the ordered pair which we will get according to the given relation. Now, suppose we are having question number 4. Okay, so just a figure is given over here. And the figure is like this: 5, 3, 6, 4, and 7, 5. And this way, the relation is there with the help of mapping diagram. We have to write it in roster form. We also have to write it in set builder form. So yes, Lena, what will be the element when we will write it in roster form? The relation R will contain
5, 3,
yeah,
and 6, 4, and 7 and 5.
6 with 4 and 7 and 5. Now, Izan, how to write it in set builder form?
Set builder form.
Yeah,
Uh,
set of all x ordered pair xy such that, now what is the relation between x and y over here?
X is greater than 5.
What? X is greater than y?
5, 5.
5 you are saying?
Yeah.
Yeah. And what
Less
is the
than equal
relation
to
between?
7.
Yeah.
Less than and equal to 7.
Yeah, that is x. But what's the relation? Okay. So now we need to define the relation between x and y. X is okay.
Relation.
X is greater or equals to 5 and less or equals to 7. That we will write it at last. Now what is the relation between x and y?
Uh,
Yes, Lena, any idea?
Y is equals to x minus 2.
You are saying y is equals to
X minus 2.
x minus 2. Let's check it. Y is equals to x minus 2. So we have taken x as a 5 and y became 5 minus 2, that is 3. We have taken x as a 6 and y became 6 minus 2, that is 4. We have taken x as a 7 and y became 7 minus 2, that is 5. So yes, this relation, whatever she told, that is correct. It is valid for each and every element. Can you see, Izan? This way we have to identify the pattern and we have to write a relation or equation or a relation between x and y, how exactly x and y the data is there in the ordered pair. Is it like 2 more, 2 less, 3 times, then 2 more? You have to identify the pattern. We have already, like in lower classes, we have solved a question related to series, no? Where 2 is there, then 4 is there, then 6 is there, then 8 is there, then 10 is there. Here, what we used to do, we used to identify what pattern is going on. So we used to say, okay, 2 plus 2, 4, then 4 plus 2, 6, then 6 plus 2, 8, then 8 plus 2, 10. So this is how the series will go. The next term will be, just a second. So the way we used to identify the pattern of series like this, that is the next term will be 12. Just by ourselves, we used to see the pattern and we used to tell the next term. Here also, while writing the relation, when this type of question is there, we will look at it closely and will analyze it. What exactly is the pattern in between ordered pair first element and second element? What exactly is happening? Okay, we have to identify that. Next is, yeah, here you were saying we have to define x and y. Yes, we can define x and y separately, or we can also write easily that x belongs to, see the diagram, see the figure, p and q is there. So we can say x belongs to p and y belongs to q. That will also be enough. And even if you are defining the way you say, that is also perfect. Okay. Now the next question is, suppose we are having a set A containing element x, y, z. And if we are having a set B containing element 1, 2. Find the number of relation from A to B. Yes, Lina, any idea? How can we find the number of relations only? Like how many relation can be made by taking this set A and set B?
6.
Huh?
6.
6? Yes, Izan, is it 6? Yes, you
Yes,
are
ma'am.
on the right track, Lina. We just have to use that 6. Okay. So how we will do this? We know number of element in set A is 3. Number of element in set B is 2. Now number of element in the Cartesian product A cross B will be 3 into 2, right? That is 6. But that will be the number of element in the Cartesian product. And how we get the relation? Relation we get. Okay, Zan also said 6 only. Yes, you both are on the right track, but this is not the final answer. Okay, so number of element in the Cartesian product, when we will list down all the element like x with 1, x with 2, y with 1, y with 2, when we will start listing down, there will be 6 elements. But how many relation can be made? Relation means it must be a subset of the Cartesian product. And how we find the number of subset? When we know the number of element. Just a second. Yeah, when the number of element is 6, the total number of subsets will be total
2.
number of subset. When 3 elements are there in a set, then total number of subset will be 2 to the power 3. When 4 elements are there in a set, then in set chapter we have done the total number of element in the subset will be 2 to the power. Like when n element are there, then we find 2 to the power n to get the total number of subset. Like one of the subset is 5. One of the subset, suppose we are having a set A having an element 1, 2, 3. Here the total number of element in the subset, like all the possible subset will be 5 will be there. Just a second. Here we used to list down all the subset, that is 5 can be one of the subset, 1 can be one of the subset, 2 can be one of the subset, 3 can be one of the subset. Like this we used to list down, and total number of subset will be 2 to the power 3. Similarly, here when 6 elements are there, then total number of possible subset will be 2 to the power 6, right?
Yes, ma'am.
So here find the number of relation from A to B. The number of relation from A to B will be 2 to the power 6. Okay. Is it clear to both of you?
Yes, ma'am.
Let's move
Yes,
to the
ma'am.
next one. Now here only let's see the concept of domain and range, and then we will solve few questions related to that. Just a minute. Let me take few examples. Okay. Suppose we are having a set A that is having an element 1, 2, 3, 4, 5, 6. Okay. And the relation R, the way we have taken the relation R, that is set of all x, y, such that y is equals to x plus 1. Here we have to write the domain, codomain, and range of R. So now we will see what exactly is domain, codomain, and range. So at first, how we used to write the relation R will contain the element from the given set, that is A cross A, that is 1 with 2. Then if we are taking x as a 2, then y will be 3. If we are taking x as a 3, then y will be 4. If we are taking x as a 4, then y will be 4 plus 1, that is 5. And if we are taking x as a 5, then y will be 6. Now we cannot take x as a 6 because there is no an element which is 7. So we cannot proceed. This is the required relation, right?
Yes, ma'am.
Yeah. Here we have to write the domain. Now, if we will look at our relation, domain are all first element 1, 2, 3, 4, 5. Can you see it, Izan and Lina?
Yes,
Is
ma'am.
all the first element are known as domain of the set. Okay, so we can say 1, 2, 3, 4, 5. These are the domain. Okay, now what's the codomain? So codomain are, when we will go up and we will look at our set, the given set A. Here all the element, because it was A cross A cross A. So here y we have taken from A only. So all the element 1, 2, 3, 4, 5, 6, these are the codomain of the given set. Now how exactly we are taking domain and codomain? Let me show you. We are having a set A with A. Here we are having 1, 2, 3, 4, 5, 6. Here also we are having 1, 2, 3, 4, 5, 6. Now once we will look at our relation. So here we can see 1 is having the image 2. So 1 is going on 2. 2 is going on 3. 2 is going on 3. 3 is going on 4. I am just looking at the structure of our relation, which we have written in raster form. So 3 is going on 4. Now 4 is going on 5. And 5 is going on 6. This is how our relation is going ahead. Here, range will always be all the elements which are having the image. So 1 is having the image, 2 is having the image, 3 is having the image, 4 is having the image, and 5 having the image. These are called domain of the given set. Okay. Now codomain means everything whatever is there in the other set. Everything, you have to all the elements, and that will be your codomain. So here, if we have this down codomain, we will list down 1, 2, 3, 4, 5, 6. Everything from here came over here. Can you see, Zan? Can you see, Zan?
No, ma'am.
So while writing or while listing down codomain, we will take all the elements from the set B or from the other set and we will write it down. That's our codomain. Now, if we have to write the range, then range will be the element, only those elements which are which is the image of any element. Okay. So here 2 is having its pre-image, 3 is having its pre-image. Let me circle it. Then 4 is having its pre-image, 5
Ma'am, I
having
can't
its
see the screen.
pre-image, and 6. Yeah, what?
I can't see the screen.
Both hear me now. Am I audible? Yes, Lena and Izan.
Yes, ma'am.
Can you hear me?
Yes, ma'am.
Okay, let's continue. So I was saying all the elements which are having its pre-image, those will come in the range. So 5 is also having pre-image and 6 is also having pre-image. So while listing down range, we will write 2, 3, 4, 5, and 6. That's it. Are you getting it? How to list down domain, codomain, and range? What is the meaning of domain, codomain, and range? Is it clear to both of you?
Yes.
Okay, let's do a few questions related to it. Suppose we are having a diagram like this. 9, 4, 25, here 5, 3, 2, 1, -2, -3, and -5. And the picture is like this. Can you tell me what will be the domain over here? What will be the codomain? And what's the range? Any one of you? According to the given figure? Izan, can you tell me?
The domain is 9, 4, 25.
Yeah. Codomain?
5, 3, 2, 1, -2, -3, -5.
Yeah. And range?
5, 3, 2, -2, -3, -5.
Perfect. So this is how we will list down domain, codomain, and range. Okay. Let's do a few questions now. If number of element in A intersection B complement is 9, number of element in A complement B is 10, and number of element in A union B is 24, then find number of element in A cross B, the Cartesian product. So what is the meaning of A complement B? The element of anyone? What's the meaning of A intersection B complement? Let's understand it with the help of Venn diagram. So A intersection B, that means the common part, but not B, that is B complement. That means complement of any set means what? If I am saying A complement, that means all the elements from universal set excluding A, right?
Yes, ma'am.
B complement means all the element excluding B, right?
Yes, ma'am.
Yeah. So A intersection B complement, that means B must not be there. First, keep it aside B. B complement means B must not be there. Okay. So A intersection with B complement is having 9 elements. So if this is A, this is B. So can I say this much is having 9 elements? B must not be there. Okay. B is just, we are excluding B. All right. Let me mark it properly. Only this red part of A, we can say, is having 9 elements, right? Excluding B, right?
Yes, ma'am.
Now the other one says A complement intersection B. So we are having A, we are having B again, and here intersection A complement and B. That means we have to A complement means what? Exclude A. So just keep it aside, the whole part, the whole circle of the A. Now what will be remaining? The remaining will be only this part of B, and that is 10. Can we say? Is it clear so far?
Yes, ma'am.
Okay. Now the next condition says that union between A and B is 24. So let's combine both the figure. Let's combine case 1 and case 2, and then we will be making the union. So here we are having A, here we are having B. This one is having 9 elements, this one is having 10 elements, but the union of both is having 24 elements. So there must be a common part, right? 10 plus 9 is 19. Still we have to make it 24, right? So
Yes,
19, 20, 21, 22, 23, and 24. Okay, 5 more element is needed, right? Are you getting it?
yes, ma'am.
So
Yes,
can we
ma'am.
see 5 is the common element? Now you can see A union B. That means everything is 24. Okay. Now we have to find A cross B. Yes, Izan, you will say. How to find A cross B? We got the perfect structure. You know what is A, you know what is B, you know everything. The union, intersection, everything is crystal clear over here in the Venn diagram. Now you have to tell me what is A cross B, the number of element in the Cartesian product A cross B. How many elements will be there? In A cross B? Yes, Lena? How we find A cross B?
210.
What we do?
We have to multiply the number of elements
Yeah. So
in
what
A
will
and
be
B.
the which two number we will multiply? You are on the right track. Okay. Number of element in A is how many number of elements are there in A? How many elements are there in A? Anyone?
14.
Exactly. How many elements are there in B?
15.
Exactly. And number of element in A cross B will be product of these two, right?
Yes, ma'am.
This will give us the answer. That's it. Have you understood how we did the whole thing?
Yes, ma'am.
So just now you just multiply 14 with 15 and we will get the total number of element in the Cartesian product A and B. Yes, Izan, is it clear now?
Yes, ma'am.
Now another question can be, if A is equals to 3, 5, 6, 9 and R is a relation such that R is the ordered pair, set of all ordered pair xy such that x plus y is less than 18. Then R in roster form. Let's write it. Yes, tell me the elements or the ordered pair which will be there in R. Anyone?
3 and 5.
3 with 5. Then can we
3
take 3 with
6.
3?
Yes.
Yes. You make the figure like this, no? 3, 5, 6, 9. Here also 3, 5, 6, 9. Now you have to take all the possibility where x plus y is less than 18. So let's take it. 3 with 3. Can we take?
Yes.
3 with 5 also we have taken. Now 3 with 6 can we take?
Yes.
Yes, we can take because 6 plus 3 is 9 and that's less than 18. We can take 3 with 9. Yes or no?
Yes.
Yes. Then we can take 5 with 3. Right?
Yes.
Similarly, we can take 5 with 5. We can take 5 with 6. Then we can we take 5 with 9?
Yes.
Yes or no? 5 plus 9 is 14.
14.
And that is less than 18. Still it's less than 18. Right? Now we will take 6
Yes.
with 3. We'll take 6 with 5. We'll take 6 with 6. Can we take 6 with 9?
Yes.
Yes, exactly. We can take because 6 plus 9, 15, which is less than 18. Now we will take 9 with 3, 9 with 5, 9 with 6. Can we take 9 with 9?
No.
Yes or no?
No.
No.
No. We cannot take 9 with 9 because 9 plus 9 is 18. And we have to follow this condition where it says x plus y must be smaller than 18. So two numbers, whatever ordered pair you are making, those addition must be smaller than 18. Then only we can write those ordered pair in our relation. Otherwise, we cannot write that. Okay, so these are the elements. Okay, the next one is, let's do it quickly. So if we are having A cross B, which is already given as alpha 1, alpha 5, alpha 2, B2, B5, B1, then find B cross A. How we will find B cross A? Anyone? Yes, Izan?
Uh, 1 alpha, like
Yeah. Then
5 alpha.
yes, we can
2
reverse
alpha.
it.
Yeah.
Okay, this is the easiest way to do it. Another way can be, you can write your A, you can write your B from the given set A cross B. That is, A is alpha and B. And B is 1, 5, and yeah, B is 1, 2, and 5. So you can list it down and then you can find B cross A, or you can directly reverse it to get B cross A. So 5 with alpha, then 2 with alpha, 2 with B, 5 with B, and 1 with B. Are you getting, Lena?
Yes, ma'am.
Yeah. Okay. So one MCQ question. Suppose A is ABCD and B is PQRS. And the options are, I am telling you what the instruction is there. The relation 1, that is A, P, B, R, C, S. Another one is relation 2 is Q, B, C, S, D, R. And the next one is relation 3 is A, P, A, Q, D, P, C, R, and B, R. After that, we are having the other relation as AP, QA, DS, and SB. And here the instruction is, according to the given set, which can be the relation. Option 1, option 2, option 3, option 4. From here, we have to select which can be relation and which can't be relation. Okay, so can you tell me which option can be the relation? Here, more than one option can be correct. No worry, we just need to identify whether the given relation can be a relation or it can't be. How we will identify that? Anyone? And one more information is there. We are looking for relation from A to B. Let's see the first relation. A with P. One of the element of set A with one of the element of set B. That is okay, right? We can have such relation. Let's see the other element, other ordered pair. B with R, one of the element of set A with another element of set B. That can also be the case. Now let's see option, the third element, one of the element of set A, then another element of set B. That can also be the case. So this is a relation. Here we can say R1 can be the relation. Let's see R2. Here we are having one of the element of set B and one of the element of set A. So okay, this relation is going like B the subset of or the Cartesian product B cross A. There from there we have taken the subset of for this relation. That is okay. Let's see the other element. C with S. Can you see the pattern? At first, it was element of B, then element of A. And now the second element in the same relation is element of A, then element of B. Can you see it?
Yes, ma'am.
Can it be a relation in such a haphazard form?
No.
It can't be. Whatever you are taking, either B cross A or A cross B, it must be, all the element must be arranged in same way. If you are taking one of the element of A, another element from B, then in the other ordered pair you must take one of the element of A, another element of B. Then in the other ordered pair also you must take one of the element of A, another element of B. And if you are taking reverse way, so you must take from B, then A, then from B, then A. This must be repeated for all the elements. So second one is not a relation. Got it? Izan?
Yes, ma'am.
Similarly, if we will check the third one, R3, let's see. A is there, P is there. Till now, well and good. Then A is there, Q is there. Still, it's fine. After that, D is there and P is there. It is okay. And then C is there, R is there. Still, it is okay. After that, B is there, R is there. So this is also a relation. Right?
Yes, ma'am.
Yeah.
If we will look at the fourth one, then A is there and P is there. Okay. After that, this is A. After that, Q is there, A is there. So we cannot take in random way. Okay. The fourth one is not a relation. No need to check ahead. Got it?
Yes, ma'am.
Next question can be, after this question, I'll give you homework and we will also be discussing about the assessment portion. So if A is equals to 1, 2, 3 and B is equals to A, B, C, then R is equals to 1B, 2C, 1A, 3A, being a subset of A cross B is a relation from A to B here 1B, 2C, 1A and 3A belongs to R. So we write one is in relation with B, 2 is in relation with C, 1 is in relation with A, and 3 is in relation with A. but two B doesn't belongs to R. So can we write 2 is in relation with B? Is it true or false? Is it true or false? If A and B is given, relation is also given. Now each and every element of the given relation, we can write it in the, like, any element of the set, we can take it and we can say this element belongs to this set, right? That we have done in the set chapter, right? So we can say 1B belongs to R. We can say 2C belongs to R. 1A belongs to R. 3A belongs to R, right?
Yes,
Here
ma'am.
it says that 2B doesn't belongs to R. So can we say 2 is in relation with B? Yes or no?
No, ma'am, we can't write.
Yeah, we cannot write because 2B is not there in our set R. Let's see whether it's there or not. 2B is not there. Can you see R?
Yes, ma'am.
2B is not there. We can say 2B is not there. So 2B will not be in relation with each other. Okay? Is it clear?
Okay, ma'am. Yes, ma'am.
Okay. Now the homework part and the assessment. Let me check. See the questions. Is there any question which is not clear to you? A is this one, B is this one, R is this one. Alpha is a relation from A to B. Then domain and codomain are written over here. Domain and range. Here also A is there, B is there with the two set. Let R with the relation from A to B. Then the phrase XY belongs to R implies that X is greater than Y. Under this relation R, we have to first list it down in the roster form. Once we will list it down in the roster form, then we have to check all the elements, whatever is there in our relation. And then accordingly, we can say which one is in relation, which one is not in relation. Okay, from there, we can also find the domain and the codomain. Okay. I will send the numbers which will be there for homework. Here, pictorial representation of function, domain, codomain, and range of a function. Still, we have not started function. The concept of function we will start on the next step. Okay, so till here, domain and range and everything you can do as a homework. Let me give the numbers. Topic 4, number 1 and 2. Write it down. I will also send it to you. Write it down anyway. Topic 4, I will send you the PDF and everything. Topic 4, number 1 and number 2. Let's see topic 3 and 2. Are we done with that? Yeah, we are done with 2 and 3. Okay. These questions we have already discussed.